Hi, and in this video I want to move our discussion to analog control because that's really what we were doing in the lab before we were forced to shelter ourselves in the house. So let's move on, and we're going to do analog so that we can then move on to actually creating an HMI screen or screens. So what I did was I created a new project, and I have the project somewhat configured. And in order to do some analog control, we need to add some analog input and output modules, or in this case they're called plugins. So the first thing I'm going to do is, in this project, I'm going to rename the project and just right click and rename, and I'm going to just rename this analog control. Again, I do this so that it's more meaningful to me. Now, before we create any program code, we need to add these plugin modules. So I'm going to cut off here a little bit and show you physically how to add a plugin module to the actual hardware. And when we come back, I'll show you how to do the simulation with the plugin modules. Hi, I thought what I'd do today is, because this next scenario that we're going to run through is that I want to now add some analog functions to the Micro 800 series processor. And what you're looking at here is my little home setup, and I have an 820 processor. You can see my Ethernet switch here. This, if you don't recognize this from the lab, this is a power supply that is can be bought separately from Allen Bradley, from Rockwell. So I have an 820, and you'll see that I have a plug-in installed. These are called plugins. This is just a blank cover. You've seen the blank covers in our lab, and this is a plug-in that I inserted. So in order to put a plug-in in, all we have to do is remove this protective cover, and some of you have already done that, but there's a little push tab on the top, and we push that in. We just pull the top forward and up, and the cover comes off. Very simple. You'll see that in here is a connector where the plug-in will go. Now, here is a plug-in. This is an analog input plug-in. It will accept two analog inputs of either voltage or current. And on the back side, you'll see that there's a mating connector and some electronics. Again, like we try not to touch the electronics. And to put this in, you'll see on the bottom side there's two little catches here that have little hook things on it. And on the top there's like a little snap connection. This is the little push tab. And to put this in, it's very simple. You look inside, you'll see there's two rectangular holes. We take this plug-in, we take those little hook guys, and we notice I'm tipping it to the bottom first. We make sure that they're inside those little holes, and all we do is rock it down and push. When it clicks, it's in. And that's how simple it is to add a plug-in. There are then screw holes so that you can screw this plug-in fast, so that during normal operation you won't have it vibrate out. Not that I think it would, but I would put screws in there. And in the manual for this particular plug-in, it tells you what size screws to use for that. So this is an analog input that has two inputs, two channels. This is an analog output plug-in that also has two channels. Alright, so we're going to actually add these to our simulator in the CCW software. And I'll see you back there. Okay, now that you saw how to physically do a plug-in module, here's how we do it in the micro simulator. So in our micro simulator, if you have the project open showing the micro 850, each one of these compartments can be a plug-in module. So all we have to do is right click on the module, left click on the module to select it. Right now, if you look at the bottom here, it's empty. We'll right click, and then we're going to add an analog input module. The analog input module is a 2080- either IF2 or IF4. The 2 means that it has 2 channels. The 4 means that it has 4 channels. We're going to just use the IF2. We click on it and it adds the IF2. This is the same module you saw me insert in the physical hardware. When we add this module, you'll see that it's added to the plug-in modules, and it also has a configuration option. So we can come over to configure this module, and we can configure this module, there's 2 channels, as either current or voltage, whichever transducer you have in the field. So if your transducer is 4 to 20 milliamps, you would naturally set the input type to current. If it's 0 to 10 volts, you would set the input type to voltage. It's that simple. You can also enable the input state, or you can disable it. So you can enable or disable the channels. Usually if you're not using a channel, you would disable it just so you don't have random noise floating around on that channel. So we're going to leave this at current. The frequency is a filtering frequency. We didn't really talk about the filtering aspects of analog modules. It's really to help the noise reduction, the amount of garbage that's on some of the analog signals, and for the most part we tend to keep that at 50 hertz, which is just below our 60 hertz line frequency. So it'll filter things out so that you won't see those high frequency 60 hertz is not that high, but you won't see those fluctuations from noise. It's a first line protection. So anyway, we'll leave it at current. In the second slot, we're going to click on it, and we're going to add an analog output module. So we'll right click analog, and we have one output module, which is an 2080 OF2. That means there's 2 channels of output. So we'll click on that, and we can also then, it appears in our plug-in modules, we can also configure this. If you take notice, they are configured to current by default. You can also do voltage. We're going to leave ours at current, and they come up default to disabled. Again, if you're not going to use the channel, you don't want to have a lot of trash, a lot of noise being generated on that channel. So I do want to do channel 0, so I'm going to enable channel 0. Even though I'm not going to use channel 0 of the output in this particular video, in the next lab, I'm going to have you guys use that channel. So we want to make sure that it's enabled. All right, so that's all we're going to add. If you can explore the different type of plugins that are available. There's a bunch of them on your own. So anyway, that's that. So the project is configured. I'm going to save that just so I don't lose it. Before we actually start then, I also have to configure the simulator. So I'm going to start the simulator. And before the simulator is turned on, we have to add those same modules to the simulator. And we do it because this is our hardware. So we do that the same way we did it on the project. We'll come over, we'll right click, we'll say analog, and it's an IF2, and we'll right click analog OF2. The difference in here is that you don't see the screw terminal connections. You actually see some what looks to be text fields, because that's what they are. We're going to be able to enter values in these areas, and I'm going to show you that. All right, so that is now configured, and I'm just going to turn the simulator off. Now, I'm going to demonstrate the scalar instruction. The scalar instruction in CCW works the same as the scale instruction does, or the SCL instruction does in Studio 5000. It's just that it's called scalar instead. It is only available in function block diagram, I think. You can look that up in the help file. So we're going to add a new program, and this time we're going to add a function block program. So under programs, we're going to right click, we're going to add, and we're going to add a new function block diagram program. So we'll click here, and I'm going to name this program Scale Inputs. And then I'm going to open it. And you'll see that the editor window now turns into this like graph paper type area, and there's no toolbox across the top like it was in Ladder. There is a toolbox, and it's along the the right margin. You'll see Toolbox. I'm going to click on Toolbox. It then shows me all the tools, and there's a little stick pin here. I'm going to stick pin it so that it stays open. You don't have to if you don't want to. You can just keep sliding over and opening the toolbox so that it collapses again. That's up to you. I'm going to keep it pinned to the window at this time. So now I'm going to add the instructions in function block. So I want a scalar instruction. The scalar instruction is an instruction block, so we'll take a block and we'll drag it in. Nothing's different so far. We get the same instruction block selector. I can either scroll that list and look for scalar, or in the search I can just start typing scale and it comes up to scalar. So it's an input output, and it's a scale real input linearly with no output limiting. The instance name comes up as default as scalar _1. I'm going to change that to scale input, and I'm going to say OK. So now I have this instruction on my editor window. You'll see that there is an input min, an input max, an output min, an output max, and an output. What these are the input is the input from the analog module. So the reading that's coming from the analog input module will go to that input point. Input min and input max are the count range for that module. Remember, we had to look that information up. It's available on the specification sheets. So we had to look that information up, and then we even had to do some mathematics to get those count values, because that's what they are. They're the count values, so that we knew what to put in for input min, input max. And the output min and output max are your actual temperature range or pressure range or your engineering unit range of your transducer. So I'm going to use a 0 to 500 degree F transducer. So my transducer is going to be a 4 to 20 milliamp transducer, which can be used for 0 to 500 degrees F. That's what I'm going to do. And I already created, or I already did the calculations so that I know what count values I'm going to be getting from my module. So now I need to provide some inputs and some input tags to this particular scale input instruction, this scalar instruction. So over in the toolbox, there's an object called a variable. I'm going to click the variable, drag it in, and I'm going to drop it first on input min. And it's going to bring up my variable selector just like you're used to. And what I'm going to do here is I'm going to get you ready to go to the HMI screen. HMI variables must be global. And since I'm going to have you do an HMI screen that's going to include a scale instruction, I'm going to create these variables in global scope. So I'm going to make sure I'm on the user global variables for the Micro 850. I'm going to click here and I'm going to type the first variable name in, and I'm going to call this max PV counts. And I'm trying to stay with the same basic tag names that we would have used in lab 7 for if we were in the lab. The data type would normally be dint. And you know what? I'm going to make it dint for this example. And then I'm going to say OK. So I have a max PV counts, and it's going to be of type dint. However, when I hover my mouse over to scalar, it shows you that all of my inputs and my outputs are data type real. So it's looking for the data type of real. Guess what that means? That means that I have to take that dint tag or that dint variable and use an any to real instruction to convert that to real. So let me do that. I'm going to drag this out here. I'm going to then do an instruction block. I'm going to find the any to real. There it is. Say OK. And I'm going to put that up here somewhat in line. Notice it got close to that. It automatically connected it. I can break that connection simply by clicking on the wire and pressing the delete key. There, it automatically wired it. It assumes that that's what I want it. So I'll leave it like that. I can move these things around, as you can see. But let's get things lined up. All right. And then I'm going to create some more variables. In fact, I'm going to create 3 variables. Only this time I'm going to create them as data type real so that I don't have to use the any to real. So let me do a variable, and I'll bring these out here. And I'm going to call, and make sure it's global. And I'm going to call this min PV counts. I'm going to make this real. Notice I'm creating them in the table because what I want to do is I'm going to create these variables while I'm here. The next thing I'm going to do is I'm going to say min process temperature, and I'll make this real. And I'm going to say max process temperature, and I'll make this real. And I think that's all I'm going to, actually I'm going to create an EU tag for my engineering units, and I'll make that real. And then I'll say, I want to make sure I select the one I want it. Let's see, what am I working on here? I'm working on input max, which is my max PV, and I think I've got that wrong. I do. I want this to be my max PV. Okay. So what I need to do, and I'm kind of glad I made this mistake and had them switched so that I can show you what you have to do to fix this and to keep things organized. I'm going to click on this line and just do a delete, and click on this line and do a delete. And I'm going to then bring this down to here. Bring this up a little bit. I'm going to just straighten this out somewhat. Notice how I don't like that. I'm just going to click on the wire, grab a handle, and bring that up. So you can do a lot of things with this. And then I'm going to change this tag. This tag, and all I did here was double clicked, and this should actually be the min PV. And then I'll take a wire and wire that to there. And let's see, I'm going to take this and just drag this out. And I don't even like that. I'm going to probably bring this down a little bit. I'm a little bit anal when it comes to this, so please forgive me. All right. All right, then I need to add two more variables here. So we'll bring a variable over to here. And this is going to be our output min, which is global variable, which is going to be our min process temperature. And I need another variable, which is going to then be our global variable max PV temperature. And I'm going to wire these. So I'm going to wire this to here. I don't like that, so I will just drag this wire to how I like it. I'm going to wire this to here. I'm going to drag this wire just to make it look a little neater. This is something, by the way, you can't do in the Studio 5000 function block. You can't like move the wires around to make them look neater. They kind of go where they go. and I never liked that about the Studio 5000 function block. Let's add our output. So we'll add a variable, and our output is going to be, again, global, and it's going to be EU, and it automatically wired it there. Again, if it wasn't to the right place, just click the wire, delete it, and then you can wire it to anything you want. So let's do that. And now I need my input. So I'm going to add a variable, and I'm going to add that variable kind of up here for now. And that variable is going to be my analog input. So that's going to be on a I/O tab. So I'm going to go to the I/O tab. I'm going to just make this window a little bigger. So it's on my I/O tab, and I'm looking for the analog inputs. So I'm going to scroll down this table, because these are the digital outputs, my digital inputs, some of my, and there's my analogs, my AI, analog input 0, analog input 1, analog output 0, analog output 1. I'm going to use analog input 0, and I'm going to call this, I'm going to give it an alias name of PV for process variable. Something I need you to note here is that this is an unsigned integer, and if I try to change that, I can't. I double clicked actually by mistake. Let me just bring that up again. It's an unsigned integer, and I can't change it. No matter what I do, I can't change it. So that means because this input has to be real, I need to do another any to real. So I'll bring an instruction block in. I don't know, I've set it here. I want to do any to real. Any to real. We'll say OK. I will then wire this and wire this. And I am done. I'm going to bring this down just to make things a little bit cleaner. Okay. So basically I'm all done with this. Unless you're as anal as I am and you want things lined up. All right. Now, I can move this whole thing. What I'm going to do is I'm done inserting instructions. Let me unpin the toolbox. I want to move this whole thing. I'm going to take my mouse and just click and drag around the whole instruction. And I'm just going to move this a little bit just because I know what's coming. I can also select just one thing or two things to move. Like if I wanted to move these two, I can go around that, and then I can just drag and move those things around. So you can there's a lot of flexibility in this function block editor. If you wanted to add a comment in the toolbox, there's a comment. You take this and drag it in. It's a little green square. You can double click, you can size it. You can double click in here, honest, and add some text. This is a scalar instruction. All right, so you can add comments. All right, so this is what we're going to do. So I'm going to add another comment to this only because I want to, where are you? There you are, okay. Only because what I want to do is put the values that I need so that I have a reference for what values. So my min PV counts is going to equal 3277 counts. And just so that doesn't wrap, I'm going to make that a little wider. And then my max PV counts are going to be 16,384 counts. My min process temperature is equal to 0 degrees F, and my max process temperature is going to equal 500 degrees F. Okay, so let me just move that out of the way. Now I can initialize these variables by going into the variable selector window and putting those in my initial values. However, when we have the HMI screen, we're going to use the HMI to enter those values. So what I'm going to do now is I'm going to save this, and I'm going to download this. And what I'm actually want to do yet is I just want to move this over to give me room to put my variable selector. So I'm going to now I've got to start my simulator. And let me turn the simulator on. Okay. All right, it's on. And then I'm going to download this project to the simulator. And hopefully I didn't make any mistakes. Okay, we'll do a download. Yes. Okay. And we are now running. You'll see that the actual values are being displayed. We have an NaN on the output because apparently there must be a divide by 0, and it's saying now, or there's something going on that's creating an error. When you see that at that NaN, that means there's been an error created during some sort of operation. So I want to change these values. So I'm going to right click on any one of the tags, and I'm going to say variable monitoring. And let me just pull this out. I'm going to make this a little smaller. And I'm going to pull this over. And my logical values is what I'm going to change. Okay, so my max PV counts. My max PV counts are going to be 16,384. This is real, so I want to put a .0 on it. My min PV counts. Oh, okay, it doesn't want that. It didn't want the .0. My min PV counts is going to be 3277. My min temperature is 0. My max process temperature is 500. Okay, so I've initialized my variables. Now, as you can see, my output's saying that it's minus 125 degrees. Well, that's how many 0 counts coming from my module would be if, in fact, my transducer could put out 0 milliamps, but it doesn't put out 0 milliamps. My minimum count from my module is 3277. So when I have 3,277 counts, I should have 0. So let's open the simulator. The simulator's running in my taskbar. I'll slide this over just so we can see the EU. We could also see the EU in here. And in the front, this is my, I can click in here and enter a value. I can enter count values. So let's say 3277, press enter. 3277, if this works correctly, should have given me 0 degrees. And it gave me 0 degrees. Notice this didn't update. If I click into the window, it updates. It didn't update because the window wasn't active. I'm going to close just to stop confusion. Bring my simulator up again. Let's see if I bring this down here more. Doesn't really matter. 16384, 16384 should give me 500 degrees, which it does. Something in between, I think it's 9840. 9840 should give me about maybe it's 40. I did the calculation, I didn't write it down. It's 9831 is about the midpoint, which gives me about 250 degrees. So my scalar instruction is working. And you can put your count values in, even though we don't have actual field devices wired to it. If you know your count range, you can enter the count range and simulate what's going on. If I had my output set up, my output would be displayed, my output counts would be displayed on this module. All right, so that should get you started for our next lab, which we're going to do. It won't be as difficult as the last time. It won't be as much work, at least. But I'm going to have you scale the data that you would expect from the Micro 800, and which means you're going to have to look up that input and output module to get the bit resolution and also the count range associated with that. Okay, check in the learning content, and there'll be a lab 2 in there before we start doing HMI screens. See you next time.